with the land. So let's listen to it. Let's listen to the land. Earth is a marvelous planet for growing things. What begins with a seed driven by the wind becomes a thriving complex of plants. Imagine them bigger than life. You can almost see them growing, using the sun's energy to take minerals from the soil, gases from the air, and water to carry these to the leaves. Plants are wonderful pumping factories, which makes our proteins and carbohydrates through a process called photosynthesis. A partnership with the land is still a challenge in some areas of our world, and one of those areas is a tropical rainforest. In its natural state, the tropical rainforest is the explosion of life, favoring many plants and animals. But the challenge of harvesting food in this environment would make it too difficult for us to live here. The challenge of the Great Desert is quite the opposite. Here, the bright sunlight evaporates water more quickly than nature can supply it. With scorching heat and howling sandstorms, you can understand why many people feel the desert is too harsh a place to ever grow food. Too harsh a place? That's what many people once thought about this land. The vast American prairie. Western fronted settlers with bad weather, natural brush fires, swarms of locusts, and other insects. But the land was there, immense and fertile. Southern settlers persevered, and in time, much of the prairie became a family farm, flourishing with many crops. Given the time, of the old red thorn that grows in the fields and animals in the yard. Now let's take a close look at the last century of American agriculture. Farms are becoming large-scale agriculture. As growing food becomes more of a science than a way of life, we now have better machines, better seeds, better fertilizers, and better pest management and research, all resulting in more food per acre. We have proof of the past bringing to the present. We have seen a lot of changes, but what about the future? How will we make the tropics and the desert of our world more productive? Well, folks, we're working on it. The crops that you're about to see are real and alive. They grow year-round, and our sophisticated greenhouses are what we call CEA, or Controlled Environmental Agriculture. Now, we don't think the CEA will ever replace traditional agriculture, but it will help increase productivity and begin to meet some of the challenges we have seen in these difficult areas. These are some of the food plants of the tropics. To grow more food in less space, we have taken coconut and then a crop of white cacao. Cacao is a source of chocolate and cocoa. tree, which produces a fruit high in vitamin C, and is also used as a tenderizer. Here on your right, stalks of sugarcane like these provide the world with about 60% of its sugars. On your left here, we have bananas. Did you know that bananas provide the world with about 1/4 of its fruit supply? And is one of the first fruits ever gathered and cultivated by man. Throughout the world, only about 8 plants have provided us with 90% of the food we eat. Most of that comes from just 3: wheat, corn, and rice, which you see growing in the rocky terraces. Tall palms, like the peach palm and the coconut, are a vital tropical source of food and fiber products. Here on your left, we have the wing bean. The wing bean is one of the few plants in the world that is 100% edible. Vanilla, whose pods are highly valued for flavoring, is the only edible member of the orchid family. A major source of protein from now and in the future is fish. Here in our cells, we're studying new ways to grow fish and other types of seafood with aquaculture. Aquaculture is the controlled cultivation and harvest of aquatic plants and animals. In this fall space, we can harvest tons of aquatic food, like the paddlefish on your left, whose eggs are a source of caviar. Here in the shallow raceway, we use special feeds, recirculating water, and control light transmission, such as the experimental red cover overhead, to get the maximum growth at our channel catfish on your left and African tilapia on your right. Here at top 2, we can take a close look at the tilapia average, American eel, and channel catfish on your bottom. The American eel takes about 3 to 4 years from birth to harvest, and we harvest that catfish at about 3 pounds. Remember the hot desert? Intense sunlight can for high-quality crops in the hot desert. If water can be provided, drip irrigation systems, like the black tubing that you'll see throughout our greenhouses, efficiently delivers water directly to the root zones. Technology like this is opening arid lands to agriculture. In the future, what grow crops require less water, such as sorghum, which is the world's 4th most important cereal crop, and is very drought tolerant, and cotton, which is also drought tolerant. And at the base of the cotton, you can get a good look at a drip irrigation system. Because greenhouses provide us with control of the wind, temperature, and humidity, they are very useful in the desert regions. Temperature control provides us with a year-round harvest. And with vertical growing, production rate in the greenhouse is up to 10 times higher than in the open desert. Air, drawn by the fans on your left, evaporates water to the wet pads on the wall to your right to help cool and humidify the greenhouses. Here in the greenhouses, we are researching advanced integrated pest management. We inspect our crops to identify them for problems. Then we select a compatible pest control, such as use of disease-resistant plants, steam sterilization of our soils, raising and releasing pest-eating insects like the ladybug, and as a last resort, very carefully controlled pesticide spray. Throughout our growing areas, we produce tons of fish, tomatoes, cucumbers, lettuce, peppers, and other types of fruits for use in our Epcot Center restaurants. Creative ideas will continue to change agriculture. We can imagine any number of innovations, like these experimental conveyors, which grows crops without the use of soil. We take the 14 essential nutrients from the soil, mix it with water, and we spray them directly onto the roots, or what is called air viva aeroponics. Future generations of settlers will challenge the harshest environments, even outer space. Here we're researching crop production for on the move in a simulated lunar sol. This sol was patterned after to the Apollo samples. These food growing systems are identical to the one in the John F. Kennedy Space Center. Along with NASA scientists, we're pioneering in space agriculture. Back on Earth, we'll place increased emphasis on conservation and human nutrition. Scientists will use tools like computers, robotics, and biotechnology to make a tremendous impact on the crops and animals. They will develop more crops that take nitrogen from the air, use light, water, and carbon dioxide more efficiently. With exciting new technology, creativity, and plenty of hard work, we can meet the challenge of producing an abundance of food to feed everyone, even in those areas of our world once thought too difficult to harvest. Our future can be limitless if we work with nature and just listen to the land.